All right, this is number 3, continued from the 2019 free response. And this is the no calculator section. So we have a continuous function. I'm just reading number 3, defined on the closed interval from -6 to 5. The figure shows a portion of the graph of f, which is 2 line segments in a quarter circle that has a center at 0.53, and they give you the 0.3, 3 minus √5 on the graph of f. Letter C says the function g is given by g of x equals the integral from -2 to x f of t dt. Find the absolute max value of g on the interval -2 to 5 and justify your answer. If you want to pause to think about what type of question this is and what you would do to find an absolute max, you can go ahead and do that right now. So hopefully you were thinking about absolute max can happen at endpoints or critical points. And maybe you also thought about this being a candidates test question, and you are right, that's what this will be. So we are finding the maximum of the g function, and this is the g function. So when I set up my table, I'm going to have x and g of x. I'm looking for the maximum, and I know right away that I can put my endpoints in that table. And here's my endpoints. So -2 and 5 are automatically going to go in the table. The other place, because that takes care of my endpoints, the other place we could have an absolute max is at a critical point. The definition of a critical point, think about that, is where the derivative is equal to 0. And so we have to go ahead and take that derivative. So let me use this notation that I learned and like. We're going to be taking the derivative of this function, of the g function. So the derivative of g is g prime. And then the derivative and the antiderivative are going to cancel out. That x will be plugged in. So that's just going to give me f of x, right? The derivative and that antiderivative cancel out. So we're looking for our critical points, and that is where the derivative, g prime, which happens to be equal to f, is equal to 0. So where the derivative is 0. So if we're looking for where is g prime, which is equal to f, equal to 0, we're going to look at the graph of f. And really we're just looking for where is the f function equal to 0, what x values give me an output of 0, where is the y value 0, all of those things. If you want to pause and think about where those are, you can go ahead and do that. It's going to be here and here and here. So those would be critical points because that is where g prime, which is f of x, is equal to 0. And so we're going to add -1, and we're going to add 1/2, and the 5 is already there as an endpoint. And if you were wondering how did I know that was 1/2, it's because I knew this slope here is 2. It's going up 2 and over 1. So when I get to this point, like I'm halfway over, right? And then if I go like up 1 over 1/2, up 1 over 1/2, you could think of the slope as that way. Okay, so that is going to be my chart. And at this point, all I have to do is figure out what is the g function at those points. And this is going to take a little bit more time to figure this out. And I'm going to erase this just so we have space and we can be looking at the graph as we work. Okay, the first one is wonderfully easy. You will love this. So we're looking for g of x. We're going to start with this -2. So I'm plugging -2 into the g function, which means it's going up at the top where the x is and replacing that x. And the area under the curve from -2 to -2 is 0. The next one, oops, sorry, I didn't mean to erase that. The next one we'll look at is 5. So plugging in 5, g of 5, we're going from -2 to 5, f of t dt. And we're going to evaluate that definite integral using the area under the curve. So from -2 to 5. If you watched the earlier video, I think it was for part A, it was part A. We did this already in part A. So we want the area from -2 to 5. It is this area, and this area, and this area, and this area, right? All this area under the curve, or between the curve and the x-axis. So what we had noticed in part A is that these two areas cancel out because they're the same size, and one is positive and one is negative. So we just took that to be 0. We also did the same thing for this triangle and this triangle, that one's positive, one's negative, but they're the same size. And then what we had left was a trapezoid. So right here, that is a trapezoid, 1/2 the height, B1 and B2, which is 1/2 of 4. So I'm going to write this area in as 2. I did that a little bit quickly because we did that in part A, but this was the height of 1, and then the bases. This is the first base of 1, and this is the second base of 3. So that's how I got 1/2 of 1, and then the bases are 1 plus 3. So that area is 2. Another thing we did in part A, you can go back and watch that if you want to, is this area was a little bit tricky. And so what we did is we made this into a square here. So what's shaded yellow is not a geometric shape that we know how to find the area of. And so what we did was take the area of this square, which is a 3 by 3, and we took out the area of this quarter circle. So that is pi 3 squared over 4 to give us 9 minus 9 pi over 4. The circle had a center at 5, 3, and so that's how we knew the radius was 3. So pi radius squared, and then divide it by 4 because it's a quarter of a circle. So if you start with the area of the entire square, which is 9, and take out this crosshatch red part, take out that quarter of a circle area, it's going to leave you with the yellow area. So finally, and if you want more time and detail on that, you can look at the video for 3A. The area from -2 to 5, we had these triangles cancel, these triangles cancel out, and then we had 2 plus 9 minus 9 pi over 4. So 11 minus 9 pi over 4. So I'm writing that in the chart. All right, the next one would be -1. So this is going to be a little bit easier. Let me erase this. And I'll go ahead and erase just this top one. Okay, so plugging in -1 means we're looking for the area from -2 to -1. So -2 to -1 is right here, and that is a triangle, so that's going to be 1/2, a base of 1, and a height of 1. And so that's just giving us 1/2. And the very last one, and I will erase down here now, the very last one is 1/2. So looking for the area from -2 to 1/2. So it's everything that is in yellow right now. And so I would use, again, that idea that this area and this area are going to cancel out to be 0. You have a positive area and a negative area that are the same size, so those will cancel out. So all we have left is this little section, and that's going to be the area of a triangle, so 1/2. The base is 1/2. The height is 1 or -1. 1/2 times 1/2 times -1 is -1 over 4. If you don't like how I put that as a -1, you can just find the area as 1/2 base times height, and then just know that it's going to be negative because the height is negative. That's fine too. Okay, almost done. So the last part is to just find the absolute max. So we're looking for the biggest y value, And this is a little bit challenging without a calculator, just because the numbers are a little bit weird. So we have a 0, we have a -1/4, we have a 1/2. Guess this is the only one that is a little bit strange. So what I did is I took pi to be around 3, right? 3.14, just so I could look at it. And then 27/4, that's close to 6 or 7, right? So 11 minus 6 or 11 minus 7. If you think about 24/4 is equal to 6, or 28/4 is equal to 7, you can take it as a 6 or a 7 if you're just trying to estimate. So it's 5-ish. Either way you are estimating that, you're going to realize that that is the highest one, because 5 or 4 is bigger than 1/2 and 0. So the last part, to answer the question, you would want to write a sentence and just say what the max is. Find the absolute maximum. So you can just write the absolute max of g on -2, right? All of that is copied from the question, is 11 minus 9 pi over 4. They're not asking where is the maximum, but what is the maximum. So you want to list that y value as the maximum, the highest y value. And for the rubric on this, it looks like you get 1 point for just being able to take the derivative of g and say that it's f of x. So that was at the very beginning. You get a second point if you knew to put -1 in your candidates test in that chart. So that's before we did all the work. I mean, really, that was the very beginning of us setting up the problem before we did all that tough area work. So you're 2 out of 3 already. And then if you were able to do all that other work and get the answer, you don't have to write a justification because the justification is your chart. That would give you the third point. So I like this rubric because there is a lot of work in this question, but they give you 2 out of 3 before you even fill in this side of the chart, and I think that's generous. All right. See you soon.